So let me move on to the other point. Sorry, I'm not quite illustrating this right. I'm missing something. But let me move on to discussion of the relativity of simultaneity. So yeah, that's what it was. So yeah, I only have 3 minutes, and I don't want to leave things here. So if I figure out what I did wrong here, I will come back. So far I've done this. I've drawn the new time axis that's telling you what all the points are that share the same point at a particular reference frame. So I have this, I have that. And we are not, so all of that is familiar. That's why I started out with it. We are not used to trying to define a set of points on a coordinate system that share the same time, because what we are intuitively used to is the idea of absolute time. So, I mean, if I point out the fact that along this x-axis, all the points here share the same time t equals 0, then that doesn't surprise you, right? And before, that would have been unremarkable. I wouldn't even bother pointing it out. And the reason I'm pointing it out now is to tell you that according to this Lorentz transformation, along this point, along this line, t prime is not necessarily equal to 0 for every one of those points. You can see it this way. Let me take the Lorentz transformation here. Let me just, out of these two equations, let me just plug in t equals 0 and see what I get, what kind of line that defines. So when I plug in t equals 0, I get ct prime is equal to gamma, or I guess 0 minus, so it's minus gamma beta x, all right? And I get x prime is equal to gamma x. Yeah? So, all right, so I guess between x prime and x, it's not all that weird. I'm just rescaling it. So something about Lorentz contraction. All right. Now, it's this thing that's interesting. So this is an equation that defines a line. And it does not define a line that's a flat. If it's defining a flat line, it would say, so what this is showing is that, so when you look at the points along this line, your value of t prime is not 0. Instead, your value of t prime is equal to minus gamma beta x over c. So there's one point here where t prime is equal to 0, but at every other point here, t prime is not 0. Okay, so I guess enough of that. I'm already out of the time, but let me just do one more thing. So instead of telling you how things are not simultaneous along this line, so this means simultaneous in frame S, but this means not simultaneous in frame S prime. So let me just try to find, okay, so what points are simultaneous in the S prime frame? So the way to do that is to take this expression and plug in t prime is equal to 0, right? Because then I'm looking for all the points that have t prime equal to 0. So let me do that. So 0 is equal to gamma ct minus beta x. So we get a kind of relationship between x and t. And I can use that to find a line that I can draw in this x-ct coordinate axis. So let me just, so ct is my y, so let me solve it in that format. So gamma, I can cancel it out. So I get ct is equal to, move this over, beta x. This is y is equal to some slope times x. So you get a line that has a constant slope, same as the velocity. So this was the ct prime axis. The x prime axis the set of points along which CT prime will be 0 is something that looks like this. So when you have two events, A and B, that are simultaneous in your unprimed coordinate system, they are not simultaneous in the other primed coordinate system. B happens earlier because the parallel line that goes through B is below this. So B happens before A happens. So this is how it looks. So this ruler, as it's passing by, you measure it and you measure both ends simultaneously in your reference frame, right? In the other guy's reference frame who's riding with the cart, this is what it looks like. It looks like you measure the front first and then you measure the back, because B happens before A does. So when he's measuring length of his own ruler, he doesn't do that. That's a crazy thing to do. So for him, when he's trying to measure the length of his own ruler, this is the ruler that he's measuring. He uses A and this event B prime here, because it's A and B prime that are simultaneous in his reference frame, not A and B. Yeah, that's what I was trying to lead to, but I did something wrong. I'll fix it up. I'll probably post a video rather than use up time in next week's lecture, but let me fix that up, figure out what I did wrong, and I'll send it out.